All right, so now we're going to do the rest of this video, or this page, and that is going to be question number 53, completing the square. So it'll be 2x squared minus 3x minus 1 is equal to 0. So before we do this one, I'm going to just create a problem, because I kind of want to show you like an easier one that you can do that is more realistic for, not more realistic, but for this one, because there is a lot of work to do with this actual problem that we're going to do, and it's going to be a little bit harder, especially if you're not allowed to use a calculator. I would suggest that this one's actually should be used for quadratic formula. But when you're completing the square, if this is a number 1 in front of this x squared, and this is even, then completing the square is really easy. If I have another number here, let's just say 2, even though this isn't 1, that if I were to that I can factor it out and get to a 1, or factor it out and get to a perfect square, then it's still pretty easy. But like in this case, there's nothing that we can factor out evenly, although we're going to do that anyway. First look is there's nothing you can factor it out. So it's going to be a little bit more difficult. But when you're completing the square, the first thing you do is you set it equal to your constant. So unlike everything else that we've done where we always set it equal to 0, completing the square, you set it equal to constant. Then you take this middle term. You can disregard the sign if you want. Some teachers will teach you to use the sign. I don't really care, because the next step you'll see, you always divide it by 2, so it's 4, and then you square it. This is why I don't really care if you use the sign or not, because when you square, it's always going to be positive. And I've noticed that some people will sometimes leave as a negative 16 if they were to leave that sign. So you square, and then you add that to both sides, because what you do to one side, you have to do to the other. And now this, after you complete the square, will always, always, always factor out into a perfect binomial square. So it will be x minus 4 squared. So the number that you get after you divide by 2 is always a number that you're going to put in. If this is just x by itself, then it's just going to be x. And whatever sign you have here is a sign that we have here, is a sign that we'll put in the middle. Negative 2 plus 16 is 14, and then we can take the square root. So then we will have x minus 4 is equal to plus or minus the square root of 14. Then we can add 4 and say x is equal to 4 plus or minus the square root of 14, and that would be your final answer. All right, so when it is just a number 1, or a number that is a perfect square in front of the x squared, is a little bit easier. When we have the type of problem that we do now, we are going to make this a little bit different. All right, let me just make this full screen. All right, so from here, what we're going to do is we're going to add over our constant, and we're going to set that equal to our constant, just like we did. So now it's 2x squared minus 3x is equal to 1. All right, normally when we factor out, we want it to be something that common multiples, but we are going to factor this out. We're going to factor out to 2, so we can get our x squared all by itself. When we factor, we're essentially dividing. So that means when we factor out a 2 here, we're left with negative 3/2 x. All right, then I'm going to divide this to the other side. So now I get x squared minus 3/2 x is equal to 1/2. All right, then from here, I take that middle number, 3/2, and I'm going to divide it by 2. So that will become 3/2 times 1/2, so it becomes 3/4. And then I'm going to square it. So nothing changes what we did, so it becomes 9/16. And I'm going to add that to both sides. All right, so it's very similar to what we were just doing, but now it's just a little bit harder because it's fractions. All right, then 1/2 plus 9/16, well, it means I need to multiply this by 8/8 so I can get common denominators. So 8/16 plus 9/16 is 17/16. And remember, I said it's always 100% going to factor out into a binomial square. Since we have x squared by itself, it's going to be x. The number that we get when we divide by 2 is the other number, so 3/4. The sign that we have here is the sign that we're writing in between. So minus 3/4 is then equal to 17/16. All right, then we're going to go ahead and we'll take the square root of each side. So x minus 3 over 4 is equal to plus or minus. Well, I can't take the square root of 17, so it's going to remain. But I can take the square root of 16, that's 4. Right? Then I'm going to add 3/4 to both sides. So then we get x is equal to 3 plus or minus the square root of 17 over 4. Since these are the same denominator, I can just rewrite my numerator together, and that would be our final answer. All right, so this one was a little bit harder than the other example I've shown you because we're dealing with fractions, but if you're able to use a calculator, it's really easy because you don't have to worry about finding common denominators or anything like that. All right, if you have questions on this one, I do have some videos within my YouTube account already that you can watch to help. All right, number 59, I'm just going to go over quickly. -2 is less than x plus 4, which is less than or equal to 7. This is actually two separate problems. We set it up where x plus 4 is greater than -2, and then we set it up where x plus 4 is less than or equal to 7. So we actually set up two different problems here. So x plus 4 is greater than -2. Remember, if you're dividing or multiplying each side by negative, so if x was negative, you do need to change your inequality when you do that. But in this case, we're subtracting 4, so x is greater than -6. Then the other one that we have is x plus 4 is less than or equal to 7. Subtract the 4, so x is less than or equal to 3. And draw a number line. So our number line will be from -6 to 3. It's an open circle, so it's not equal to, it's just greater than. So it's an open circle. This one's equal to, so it's colored. And that will be our solution. So anything not including -6 but greater than, up to and including 3. All right, so before we get into 62 or 63, I'm just debating on how I should explain this to you first. Because if you recall, if I said the absolute value of x is equal to 5, x actually gave us 5 or -5 as an answer because absolute value, we're dealing with the distance from 0, and it can +5, the absolute value of +5 is 5, and then the absolute value of -5 is 5. So when I'm not going to show you using a number line. If you're confused by what I'm doing here, let me know and I can make a video going through why this works. But I'm just going to show you what to do rather than, since I'm not in person to answer any of your questions, showing you exactly how and why we're going to do what we're going to do. It might cause for some confusion. But whenever you have absolute value, you know it's going to generate two answers because we know that this can be positive or negative. And because it's positive or negative, it's going to generate two separate answers. So whenever you have this, the first thing you do, just like I said before, is you isolate your absolute value. All right? You always isolate your absolute value. All right? Now, this is not equal. This is less than. So whenever it's less than or equal to, if you sound less than, it sounds like we're saying the word and. So this is an and statement, meaning that it has to satisfy both at the same time. Whenever it's greater than or equal to, if you think greater, it sounds like we're saying the word or. So this is an or statement, meaning that either one of our solutions work. All right. So when we're solving this, the first thing you do is you write down exactly what you have. Just remove the absolute value signs. 2x minus 5 is less than 7. All right. Then it is n because it's less than, so you write the n in between. So it has to satisfy both of these. You always write whatever is inside your absolute value. That never changes. It's never going to change your sign there. But then your second one, you flip your inequality, so it's greater than -7. So we write it exactly as is. And then the second one, we flip the inequality and we make this negative. And then we just solve. So we will add over 5. So 2x is less than 12, divide by 2, x is less than 6. And add by 5, 2x is greater than -2, divide by 2, x is greater than -1. Right? So now, since it's an and statement, it has to satisfy both. So we can plot -1, 6. Well, x is greater than -1, so it's an open circle, so it's all the way out here. X is less than 6, open circle. And when it's an and, this is why it's important, it needs to satisfy both. So it means this is our answer, from 6 to 1. Anything out here, yes, it is less than or greater than -1, but it's not also less than 6, so it can't be part of our solution. Anything here, it is less than 6, but it's not greater than -1, so it's not part of our solution. So our answer, that's why it's important to know when it's and or, because and they have to overlap. And if they don't, then there's no solution. All right, let's do the next problem. All right, the next one is 3x plus 4. The absolute value of 3x plus 4 is greater than or equal to 2. So the first thing we do is we think about the sign. Greater, that means it's going to be an or statement. So then we just rewrite it exactly like we have, but we just get rid of the absolute value. Then we write or in between, and then our absolute value part never changes. We flip our inequality, and we make our answer negative. And then we solve. We subtract 4, so 3x is greater than -2, or x is greater than -3/2. We subtract 4, 3x is less than or equal to -6, divide by 3, x is less than or equal to -2. And this is the key difference here. Since it's or, we don't have to worry about where they overlap. If they overlap, it's actually it changes our solution a little bit, but we don't really have to worry about that part. But here's -1, here's -2, 0, 1, 2. Right? And all we do is we just graph these. All right, this is actually a good example because when we graph these, it's going to be a closed circle, so it's greater than -3/2. Actually, I'm sorry, I didn't realize it said -2. I thought it was going to say +2 for some reason. So that's there. And then the other one, we just graph here, less than -2. It's this way. So all of this is our solution. So we don't care about if they overlap and we take everything, it's all real numbers, but here we just graph them. So unlike the other one where we have to look for the intersection, this is actually saying that the only solutions that we don't have are between the number -2 and -3/2. So anything in between there is the only things that can't work as a solution, but everything else does because it's the word or. If it was and, then we have to look for the overlap, or we don't. All right, one last question and then we're done for this video. All right, so this last one, if you notice, it's an inequality because it's greater than, but it's a quadratic because we see our x squared. So this one's a little bit trickier. And what I'm actually going to show you here, you will use in calculus as far as like testing regions. So you solve this just like you would if it was a quadratic equation where it's equal to 0. So we subtract 10, and then we do 4x squared plus 3x minus 10 is greater than 0. We then need to factor this out, or if you want to do quadratic formula or completing the square, but I'm going to factor. All right, so then I'm going to use the x method. 4 times -10 is -40. The 3 drops. Numbers that multiplied to a negative, so I know it's going to be a positive and negative, to 40 and have a difference of 3 is 8 and 5. And since this is positive, 8 must be positive and 5 must be negative. I'm going to divide each one by that a because I multiplied the a and the c to get to this 40, so I divide it by 4. Then I reduce, this reduces to 2 over 1. So then I have, remember we started from the bottom, so it's 1x, so x plus 2, because now we're here. We started from the bottom, now we're here, so times 4x minus 5 is greater than 0. So now what we do is we set this equal to 0. So we're finding what's called our critical points. So x plus 2 times or is equal to 0, and then 4x minus 5 is equal to 0. So then we say, okay, x is equal to -2, or x is equal to, add the 5, divide by 4, 5/4. Right, so this tells us when it's equal to 0. So this gives us an idea of what our graph can look like. But we draw our number line, and we put this on our number line. So we have -2 and 5/4. Right, because this is when it's equal to 0. So now we want to know, well, what region is greater than 0? So then what we do is we pick a point from any of the regions. And you don't really even have to write it in too much. I'm just going to rewrite this over here, x plus 2 times 4x minus 5, and it says greater than 0. That was our problem that we had. So I'm going to pick -3. So when I plug -3 in, all I have to do is think about the signs, because we just need it to be greater than 0 or less than. So when I plug in -3 here, this is negative. So it becomes negative times. When I plug in -3 here, this will be -12 minus 5, so it's still negative. And then we're asking, is that greater than 0? Negative times negative is positive. So yes, that is greater than 0. So I know this region is a positive number, so it means it's greater than 0. Right? Then I'm going to substitute in for another region. So between -2 and 5/4. So I'm just going to pick 0 because that's the easiest number usually to work with. Well, that will give me a positive because 0 plus 2 is positive. 0 and then minus starts at negative. So this multiplies to give us a negative, and that is not greater than 0. So this one does not work because it's negative. And then the last region that we're going to do, that we're test, is going to be here. So it's greater than 1.25. So I'm just going to pick 2. So 2 plus 2 will give me a positive. 2 times 4 is 8, minus 5. It's still going to give me a positive. Positive times positive is greater than 0. So yes, it's positive. So now after I do and test these critical points, this tells me my solutions because I'm looking for what regions or what part numbers are going to give me something that's greater than 0. So that means from here to here will give me greater than 0. So it's from negative infinity, because this goes to infinity, comma, -2. And since this is not equal to, it's just greater than, it is a parentheses because we will not include the -2. If it was included and it was equal to, then it would be -8, -2 with a bracket. And I did that with you on the first page. But since it's just greater than, it is a parentheses. And then we use this symbol, which means union, because it could be one or the other. And then we write the region from here. So once again, since it's just greater than and not included, we will write parentheses, 5/4, and then this goes to infinity. And remember, when we use infinity, we can never, well, even if this one's written sloppy, I'm using it, whatever. We can never write a bracket for infinity because we can never include it. So these are all the numbers that if we plug in will satisfy our inequality. So you're finding what's called your critical points. And that's when it's equal to 0. And then you're just testing each region to see, does this give us positive or negative or positive? And if this number, instead of saying it's greater than 0, if it asks us to be less than 0, and it was this instead, then our answer would be this region because it's only when it's less than 0, and it will be -2 to 5/4. So it all depends on what they're asking for in your problem. All right, but we do what's called these critical values. We're testing them, and in calculus, you'll do this for your first derivative test and your second derivative test, so you'll do this quite frequently. So being able to do this is very important. All right, so that's it for this video and for this page.